Okay, 7.4 trig ratios. You guys probably don't have any exposure to this before, so these up here are all of your trig ratios. So we have sine, cosine, and tangent, and we abbreviate those like sine, cosine, and tangent. And these are relationships from sides and angles, and be cautious, they only work on right triangles. Okay, so the phrase I'm going to have you guys memorize is SOHCAHTOA. SOHCAHTOA tells you what trig ratio we're using. So SO is for sine, CA is for cosine, and TOA is for tangent. And then the next two letters are the sides that we're talking about. And the first one's on top, the second one's on bottom, and you're just creating a ratio. So let's label our right triangle. So let's do one before I give you the example. So in a right triangle, the side that's across from the 90-degree angle, that's the hypotenuse. Okay. And if I am talking about this angle right here, down here we call that theta, the one that is across from that angle, that's the opposite. And the one that's directly next to it, that's the adjacent. Okay, so if I am doing example 1 and I give you guys this triangle here to the right, you have a 3, 4, 5, and I ask you for the sine of S. So this is the angle that I'm talking about. So I go to that triangle and I go to angle S. And so I'm going to label all of my sides. So across from the 90, that's the hypotenuse. Across from the angle that I'm talking about, that's the opposite. And the other one is the adjacent. They would like me to find the sine of S. So the sine of S is the opposite over the hypotenuse. So if I come back over here, the opposite was 3 and the hypotenuse is 5. So that fraction is 3 over 5. Okay? If I do the cosine of S, if I look up here, cosine is the adjacent over the hypotenuse. So I come over here, the adjacent is 4, the hypotenuse is 5, so that is 4 over 5. The tangent of S is opposite over adjacent, so the opposite is 3, and the adjacent is 4. Okay. The hypotenuse is always going to be the hypotenuse, but the opposite and the adjacent change depending on the triangle that you're talking about. So if I'm talking about the same triangle, let me label it again. And I go to angle R, talking about this angle. This is still the hypotenuse, but now the opposite is 4 and the adjacent is 3. So if I go to do the sine of R, the sine is the opposite over the hypotenuse. So the opposite is 4, the hypotenuse is 5. If I go to do the cosine of R, it's the adjacent over the hypotenuse. So the adjacent is 3, the hypotenuse is 5. And if I go to do the tangent, that's the opposite over the adjacent. So the opposite over adjacent. And there you go. So we're going to use those to solve for missing sides and missing angles. Okay, so the next thing you need to know how to do is trig functions on your calculator. So get your calculator, go to mode first, make sure that degree is highlighted. If it's in radians, it'll look like this. We're not doing radians, so go over to degree, arrow over, and hit enter and make sure it's there, okay? So your trig functions, guys, are right here. You have sine, cosine, and tangent. So the very first one I want you to try on your calculator is the cosine of 48. So you literally hit in cosine, 48, enter, and you get 0.669. So if I were to find the cosine of the sides of this triangle and do a ratio and simplify it, I would get 0.669. The sine of 85, so sine is right here. Sine of 85, enter, and you get 0.996. Okay. So why this is useful is really like example 3. Dakota is standing on the ground 97 yards from the base of a cliff. So right here is the cliff. If you see it up there, here's the base, and he's standing 97 yards from the base. He goes ahead and measures the angle formed by the ground, and he decides that it is 56 degrees. Find the height of the cliff to the nearest yard. So you always want to use the angle that I give you. Okay, so label your sides. Across from that angle, you have the opposite. Across from the 90, you have the hypotenuse, and the other one is the adjacent. You always want to use the sides that you are, 1, looking for, and 2, have information about. So the trig function that uses O and A, if you write out your SOHCAHTOA, O and A is tangent. So we are going to do the tangent of this angle should be the opposite over the adjacent, which is 97. The tangent of 56 is just a number, right? We just figured that out. It's just a number. So we're going to solve this like we would a normal equation. So this is x divided by 97. So to undo that, to move it to the other side, we're going to multiply. So you have 97 tangent 56, and that equals x. This is what you're going to enter in your calculator. So you're going to do 97 tangent 56, enter. X equals 143.8. 43.8. And it says to round to the nearest yard. So we're actually going to call this 144 yards. Okay. Now we need to be able to do the inverse operation. So what if I give you sides and I want to know what that angle was? We can do that also. So I want to know this angle, so let's label our sides. Here's the opposite. Here's the hypotenuse. And the last one is the adjacent. So I think I'm missing a picture here, guys. So let's go ahead and find the question mark. So I have the O and the H. So if I look at SOHCAHTOA, the one that uses O and H is sine. So the sine of something that I don't know, we call that theta when we're talking about angles, is the opposite, so 11, over the hypotenuse, 27. So I need to move the sine to the other side, which means I need to do the inverse operation. So theta is actually going to be the inverse sine of that fraction. So on your calculator, you have the inverse sine. It's right above there. Mine's blue. So in order to get it, you're going to go second sine. Notice you get that -1. Then you're going to put in this fraction, 11 over 27. And it tells me that that angle was 24.04. And that's it. So you guys have practice all, so you guys are doing all of these. We'll also have a review on Friday when I get back. Work on this worksheet and get it uploaded.